especially about eating in the Anthropocene with Cathrine, Kramer and Zack Denfeld, about a different way how to cook our meals and how to get new ideas what to cook in our kitchen. So in the end we will have around 10 minutes of a question and answer with microphones, and we also have a signal angel here, so if there is already somebody awake in the streams, you can ask questions there IRC and Twitter. So let's have a nice talk and welcome them with a warm applause.
So thank you very much for coming. We figured you're here either because you're really interested in food or because you don't speak German. And if you're the latter, we're okay with that. I don't speak German either. She does a little. So I'm Zack.
And Kat.
And we're from the Center for Genomic Gastronomy. So all of the research that we're showing you today can be found on our website. We'll put up a link later, genomicgastronomy.com/ccc. A lot of the work that we do is in Wikipedia articles and editing them, so we'd be happy if you helped us edit those. And then there'll be a lot of other links there if you want to follow up.
So we do various things from updating Wikipedia pages to cheese wrestling and hosting Planetary Sculpture Supper Club, and these are all sort of outlets for our research and ways of talking about things. And so what is genomic gastronomy? Well, it kind of started as an antithesis to molecular gastronomy, so trying to take into account politics, economics, and culture and technology into how we eat and food, so a systems approach to food, basically. And these are some of the technologies we've been looking at. We have a very broad definition of technology, which I think is useful to put it into a kind of historical lineage, and it helps put a perspective on sort of new and emerging tech. So, that's...
So we're just starting this duo lecture thing, so if we stand awkwardly behind each other, it's okay. We're not bored. We'll get better at it. So we think that freedom of information should apply to food, and we want to work towards an open food culture. And sort of that's why we're here today at this conference. We're amateurs or hobbyists. We're actually artists, but we have no official qualifications within food science, food systems, agronomy, anything like that. But we spent 2 years getting really geeky about this subject, and we're looking forward to questions and hopefully getting other people in this community interested in food. And we do think this directly relates to computing. You can think of breeding as just very slow programming. And so if you're trying to copy and paste a carrot genome, it can actually take a year or even 2 years. You have to be really careful about cross-pollination, or your information will get corrupted. And so you want to make sure you have lots of backups, and you have a distributed network of different people keeping rare breeds of carrots alive. That's one metaphor we could use. If you're lazy like me, you don't want to code, you just want to hack, probably you want to work in the kitchen, because you can just sort of slam stuff together and do interesting stuff very quickly. And even if you just eat with some intentionality, it's an easy way to get involved in food and thinking more critically about approaching food. And so why should we care about this? Well, humans are reprogramming the biosphere every day. Our talk is called Eating in the Anthropocene, and the Anthropocene is the name that some geologists are starting to give to our current era, where the activities of humans are basically disrupting the entire planet's ecosystems and biosphere. And so we're also increasing a lot of the decisions about the agro-eco-culinary system in the hands of few. And part of that is because a lot of it's really boring or hard to understand. And that's something that this community has done a really great job of, is making things that are technical or difficult to understand at least interesting or exciting and getting people involved of. And then last, we're losing a lot of genetic diversity. Even within agriculture, there's a huge reduction of genetic diversity underway, and a huge privatization of the commons and a consolidation of ownership. And so when we were proposing this talk, in part I was inspired by attending the New York Hackers on Planet Earth conference. And this is Mark Powell, who goes by Gweed and runs a site I think called foodhacking.com. And he's an amazing molecular gastronomist, and he's working with do-it-yourself sous vide machines, cooking with liquid nitrogen. And I think a lot of the gateway drug for sort of the hacker maker community is to make hardware for the kitchen, hack their own hardware. So you have people like Seattle Food Geek, There's the book Cooking for Geeks. So that's all really cool, but what Mark Powell did that was even more interesting is he introduced the idea of seeking out less eaten foods, like rare breed celeries. And so that's what he was cooking here at the Hackers on Planet Earth Conference 2008. So that was a big inspiration for us doing this talk. So we're going to tell you about today's ingredients.
We've set it out on a kind of linear time scale to make it a little bit easier. So starting with orange carrots in the 1600s, potatoes, mutagenic grapefruit, fish tomato, BT brinjal, glowing sushi, and finally smog. And if we get around to it, we'll talk a little bit about the future as well. So starting with the carrot.
So take a look at these carrots, just a few different varieties, and you can see that we've been hacking the hell out of this genome basically since the dawn of agriculture. So they think the modern carrot arrived sometime in Europe between the 8th and 10th century, and it came in colors of red, yellow, and orange. And it actually wasn't until people started selectively breeding carrots to be less bitter that a sort of viable orange variety came out. And that had a secondary purpose, which was orange, which was the color of the Dutch royal family. And so the carrot wasn't made for them, but once there was an orange carrot, it sort of helped things along. So now that all these intellectual property regimes have been coming into place over the last 50 years, we're realizing how many biohackers have never gotten credit for the work that they've done in the thousands and thousands of years of agriculture. It's something we should really try to give credit for. So how many people here eat purple carrots on a regular basis? We're going to talk after. There's one guy here, so that's cool. Oh, two? Who's the other one? So we'll talk about that. But you can find purple carrots in some specialty stores, and if you can't, you can grow your own. And I think we try to really stay away from the word natural in these conversations because it gets sticky quickly. So the diversity of shape and color and flavor, the agronomic characteristics, the culinary characteristics of these carrots all came from the original plant of Queen Anne's lace. And so we've selectively bred these vegetables to have these huge roots that are sweet and large and colorful and benefit humans. And they do stuff for other animals as well, good and bad. So for this talk, forget about nature. Let's be specific. Orange carrots dominate carrot crops the world over in supermarkets because of human preference, not because of anything from nature. So what we can do to be specific is ask how the particular ubiquity of the orange carrot all over the world with our 7 billion human eaters is affecting the agro-eco-culinary system. It's a really specific question that's different than talking about something that's natural or not. So most of us do our work up here. Population has been exploding, and farmers not so much. In the US, as an example, where I'm from, less than 1% of the workforce does agriculture full time. So that's not to say that we don't have a huge effect on food and what's grown. As eaters, we make upstream decisions every day based on our preferences. Farmers, markets, all different things downstream are affected by the choices that we make. Especially those of us that have some privilege and come from places with abundant choices and lots of nutritional options, we can really make a difference as eaters. If you want to get really geeky, you can go down to the farming section and we can talk more about that at the end. But don't feel not empowered as an eater. You have a huge amount of power. And so we like to say eaters are agents of selection. And when we think about genomic gastronomy, sort of that's our tagline, a way of eating, it's about the relationship between the agricultural biodiversity, which is the kinds and number of organisms in the food system on the planet that feeds all humans, and how that relates to things like taste and preference and texture, and not only what's efficient or what is going to make the cheapest fast food. And so all of our decisions as eaters affects things on farms, which affects lots of other organisms. So there's definitely a closed loop system that we can interact in. So if we're going to be eating in the Anthropocene, this might be the appropriate quote. The choices we face are not whether the choices we face are not whether or not to modify the environment, but how. We're obviously affecting the environment on a planetary scale, and so we should eat with some consciousness. And for a lot of you, I'm not going to assume what you eat, but I've seen a lot of Club Mate bottles and Dorito chips here, unsurprisingly, and so it may be a more difficult stretch to change your eating habits than you might change other habits. Okay, so that's sort of the overview on the carrot really quick to keep you thinking of the color orange. I'm going to talk to you about potato, which is really at the center of our story. So historians call the swap of organisms after Columbus discovered America the Columbian Exchange. Still, I wish there was a better name, but that's what we use. So it's sort of all of the stuff that went from the New World of the Americas to the Old World of Europe and parts east. And you can see it's quite a few things. So, before 1500s, there was no potato, there was no tomato, there was no corn, there was no chili anywhere outside of the Americas. Which is really not that long ago. Even things like coffee or chocolate or chili peppers, the thing that gives all these flavors and pleasures we might want to focus on. But the potato is actually really essential to the history of food. So we just pulled this data yesterday from the FAO UN data, and this is just an example of a little bit of view of some of the plants that Germany eats. And it's grams per capita per day, apparently, on average. So besides wheat, the next three really big things all came from the Columbian Exchange: potatoes, corn, and tomato. So if this thing didn't happen, you'd really swap it out.
You should check calories per capita per day because potatoes and tomatoes are mostly
They are very heavy. I'll do calories in a second. I have it. Thanks. Yeah, this is grams per day, so they're really heavy. And in fact, the biggest thing on this list is beer, which is 410 grams per day. We want to give a couple different views of data. So this is the world one, and as you can see, there's sort of a wheat, potatoes, rice, and corn play a huge role. And a lot of corn obviously is fed to animals, which is not shown here. So imagine Indian food, which I love. I live a lot in India. Over the last 5 years, I spent most of my time there. And I'm looking at the food, and I'm thinking, what would this food be like without tomatoes, potatoes, or chili? Pre-Columbian Indian food would be totally different. So we think of cuisine as being fairly static, but it actually moves incredibly fast, especially if we're talking about ecological and geological timescales. 500 years, obviously nothing. And now that our food is creating pressures on planetary scale ecosystems, decisions like tomato or no tomato the world over are really interesting. So this is what this fellow up here was just asking for. This is actually not by grams, but by calories. So about 50% of our calories on the planet come from just 4 crops. Rice, corn, wheat, and potato. And then 95% of our calories come from just 30 crops, which means there's a long tail that goes here all the way around the room for everything else that we eat. So things have changed significantly since 1500. And one of the reasons we're seeing this long tail effect is because we have a hugely networked global food system. So you're getting this concentration at the top where you used to have local cultures that would survive on barley or sorghum or sweet potato, not as much as we have a huge networked economy. And like any network, you have the long tail effects, and you also have really brittle effects. So if there was a blight horribly that took out all the potatoes in the world, like happened in Ireland once, you'd have a huge problem. So the same network effects that apply to sort of computer networks are also applying to our food system, and we're seeing this sort of winner-takes-all phenomenon of these top crops. So we were recently doing research about a month ago in Ireland, and we were visiting the Irish seed savers, and they introduced us to this varietal of potato, the Bute potato. So during the Irish famine, a few communities in Kerry ate this potato just because they preferred the taste than the other potatoes that were on offer, and it wasn't affected by the blight. And so this one community actually survived the Irish potato famine and didn't have the sort of deaths from starvation or out-migrations because they had access to this potato. And the Irish Seed Savers is this awesome group that's still keeping this potato varietal alive. So there's a lot of these groups around the world, and I don't know how much you guys know about them, but I think there's really great opportunities for collaboration between this community and seed-saving communities. And I know that that's already happened a bit in technology communities. So you can yourself become a seed defender if you want. And of course, in terms of thinking about security, I was at a think tank in India, and I just randomly grabbed a book off the shelf, and I ended up with this collection of papers from a Russian-American workshop on high-impact terrorism, and there's a paper on food security and agro-terrorism. And so this is from the year 2000. It's a really strange thing because the way contemporary agro-terrorism is conceived of to security experts or terrorism scenario planners directly contradicts the things that industrial agricultural companies, corporations like Monsanto and Dow would want. So they would like to see a further consolidation of the food chain and commodification, but the security apparatus understands that that makes it really brittle. So there's a cognitive dissonance in the halls of power, which makes it still a really interesting and open space because it seems like you can't really figure out what to do. And if you look at this list, this is someone making recommendations to Russian and American security experts. It reads like a wish list of the Transition Town movement, or I don't know, in Germany maybe you have them, if not the Green Party. It reads like a peak oil preparedness list. These are all things you would want to do to prepare for agroterrorism, and yet they directly contradict the needs and desires of companies like Monsanto. So it's a strange contradiction. And of course, you can't have a paranoid and confused military, industrial, agricultural, corporate complex without the dystopic literature of resistance. So in terms of sort of the biopunk space, I highly recommend Wind Up Girl. It's a really interesting book, and it's sort of post-climate change flood in Thailand, and the entire economy has reverted to using calories as a currency. And there's a lot of sort of genetic hacking of different plants. So it's a really interesting book I'd recommend in this space. In terms of some of the things we could do about this directly as eaters is just to get really fetishistic about cultivars and to not eat just the plain white potatoes. There's purple potatoes, there's red potatoes. Just getting really kinky about what kind of potatoes you put in your mouth could be hugely effective. Some of the things that this does is it makes other fitness functions in the global food system other than efficiency, right? Like big companies want really efficient potatoes that grow fast and aren't susceptible to a lot of blight. And this is a way of reinforcing diversity and resilience. So just being really stupidly geeky about the kinds of and diversity of potatoes you eat could be a really small, interesting change. And you know what goes great with potatoes? Butter. We were in Norway last week, and Kat's mom was actually going to ask us to smuggle in butter, because as you may have heard, there was a massive butter crisis, and Norway, one of the richest countries on the planet, was brought to its knees. So this is just to say that these food systems are severely fragile, where even a country like Norway can be affected overnight when butter is not available. And things like the carrots, which were orange and were preferred, I mean, they were sweet, but they were also preferred as orange carrots because they had to do with politics and cultural preferences, are an example of the way that things may start off as novelty items and then just spread. And so we were going to talk more about the space potato and have cut a lot of it out because we haven't found good English language press on it. And I don't want to mislead you, but from what we can tell from the few BBC articles and other documented evidence of this, is there's this sweet potato, actually not a potato, sweet potato that the Chinese sent into space and brought back down. They have sort of state-sponsored celebrations on Valentine's Day because it's purple and looks like a heart, and where they have cooks cook with it. And so it's an interesting symbol of sort of national strength and the space program. And so it's not that this particular sweet potato is agronomically better or better for cooking, but it has this sort of message that it carries, and so people might prefer it. So that's just an example of how things might spread. And so now we'll go behind enemy lines.
So the next ingredient is grapefruit, and this story starts with another technology. The atomic bomb was a significant scientific discovery and a demonstration of innovation and engineering, in engineering and warfare. And it was detonated twice in 1945 in Japan, where 200,000 people died, and today it's also known as a weapon of mass destruction and is a catalyst for ongoing kind of war and conflict. So you can start to ask yourself, is all innovation good, and what is innovation? How do you classify it? So post World War II, nation states with atomic programs started to search for peaceful applications for they basically started Atoms for Peace in the US and exploring potential uses within agriculture, medicine, and industry. So this was launched in 1953. And Paige Johnson, who writes the Garden History Girl blog, has researched this extensively. And here you see two gamma gardens, one from 1958 in the US, and this one on the right is a contemporary gamma garden in Japan, which is basically radiation breeding facilities. So This is a quote. Yesterday, I held in my hand the most sensational plant in Britain. It's the only one of its kind. Nothing of its sort has ever been seen in the country before. To me, it has all the romance of something from outer space. It's the first atomic peanut. It's a lush green plant and gives you a strange, almost alarming sense of thrusting power and lusty health. It holds a glittering promise in its green leaves, the promise of victory over famine. So this shows how some people were quite enthusiastic about this new application of atomic energy. And whenever a new technology is introduced, the debates tend to be polarized. So you have the supporters saying that, oh, atomic agriculture will save us from famine, and you've got the critics who are horrified that we could continue to propagate such a destructive technology. And today, more than 2,500 crops, mutant crops, have been officially registered with the United Nations and the International Atomic Energy Agency, and 3/4 of that is from gamma radiation. And as you can see, it's happened also on every continent except Antarctica. And the most recent one that we've found is at the plant biology department at the University of California at Riverside. They announced the successful creation of Kino LS, and this is a sweet and seedless fruit which has been approved to be available in nurseries since June 2011. If you're interested in finding out what you can find in your neighborhood, there's the meta database, IEA, it's a bit of a mouthful, but yeah, so you can look it up because, despite wide acceptance of working with nuclear materials, it's still needs some paperwork. So just as a random test, we were in Portland, Oregon, and we went to the local supermarket and picked the 3 available grapefruits because we'd heard that grapefruits have been radiation bred in the US. And so we took the first one, which was a star ruby, and it showed up in the database, and it was officially approved in 1970, preferred for its seedlessness. The second one was Rio Red, and this too came up on the database, and it was preferred for its deep red color. And the third was called, apparently, Star Grapefruit, which didn't show on the database, and its exact origins remain slightly undiscovered for us. But 2 of the 3 that we came home with came from mutagenic breeding, which isn't exactly a great sample size, but as a small local experiment, it was interesting. So it seems that when hopes and dreams and fears and nightmares subside, one is left with some seedless oranges. And mutagenic breeding, it didn't quite end starvation, but and many people are eating mutagenic varietals without even knowing it. So you could occur that mutations occur all the time naturally, so this is speeding up a natural process, but we've already talked about, And the relevance of this history is really striking to the GMO debate, and it's time to be kind of honest about what technology can do for food, because it won't single-handedly end world hunger, and it's embedded in a messy tangle of politics and economics, and I think it's time to sort of acknowledge that and include that in these debates about emerging tech. So here's a map which maps all the current nuclear reactors in the world, and it's with earthquake lines from maptd.com. And so considering recent events in Japan and the number of aging nuclear reactors in the world, it's not really hard to imagine a future where amateur bioprospectors are sort of trawling through unintentionally radiated fields looking for surviving cultivars. And we can never quite predict the exact outcomes when introducing a new technology. So looking for Germany on the IAEA's database, there's 171 matches. The most recent, or actually they're not the most recent, but they're just various ones I picked. So there's barley, fava beans, and cumin beans. They've been applied for, so this is applying for planting, not necessarily for commercial use, maybe for experimentation and that sort of thing. But yeah, so one is to improve plant architecture, and yeah, you can find all of this information quite easily. So next up is the tomato.
So we continue behind enemy lines from radiation breeding to genetically modified organisms for agriculture. And so we're interested in asking strange questions about GMOs that haven't been asked before. So one was, where do failed GMOs go to die? So you make this genetically modified organism, and what happens to it? So we glommed onto this fish tomato. And so, when I was like a teenager, I'd go to these punk rock shows, and I remember there'd be a poster with like a banana being unpeeled and a fish inside, or like, a needle being injected into a tomato. And I was really struck. I was 13, but these images are really powerful to me. And so when we started getting geeky about this 2 years ago, I was like, yeah, whatever happened to that fish tomato thing? And it's a really important story because this image and idea is really strong in a lot of people's heads, and the idea of a fish gene being inserted into a tomato plays with a lot of cultural assumptions and brings up a lot of fears that people have about this technology. And I started just doing some preliminary research, and it was really strange because a lot of the histories of biotechnology that I was reading claim that it never existed, the fish tomato, or that they just ignored it altogether. And some books I read even claim that the fish tomato was a figment of activist imagination. And I'm an activist, and I'm friends with a lot of activists, and our imagination's just not that good. So I didn't buy that one. So it turns out there was a fish tomato. It was a tomato with an antifreeze gene that was isolated from a winter flounder inserted. And the idea was to create a frost-tolerant varietal of tomatoes. So you could put the tomato in the ground, a frost would come, and the tomato plant would survive. So this image is from a 2003 BBC article, which is no longer on their website anymore. It just says article needs fixing. But we have a screenshot of it that we can share with you. And so did the fish tomato ever exist? How do we find this out? This is a really funny story. I was teaching a color theory painting type class in India at an art school. And I don't like painting that much. So I said, we're going to study the color of vegetables. And my students were like, cool, you always do weird stuff, whatever. So I said, can you tell me what color the fish tomato is? And I told them the story I just told you. And I said, here's the internet, I'll see you in half an hour. And within half hour, one of the students came up to me and says, hey, I found this document, is it useful? And I was like, this is amazing, this is like the gold mine. And so what it was is these typewritten documents from the 90s had been scanned and finally put into an archive. And so you can see here, this is permit number 91-079-01, tomato, antifreeze gene, fancy word I can't say, protein A. So this was a field test application by this company, DNA Plant Technology, to the USDA, and so they basically got permission to test this plant in California. And so was the fish tomato ever grown outside of the lab? We don't know because the US laws are really strange. They just require companies and universities like DNA Plant Technology to apply for a field test permit, and once the company gets permission, they don't have to report back. So we don't know, in fact, if this was ever tested outside the lab. One might assume that it would if they went through all the process of filling out the paperwork. So the trail sort of goes dead there in some ways, but you may have heard about the company DNA Plant Technology. Did anyone see this movie, The Insider? Sort of famous. So this is the sort of story of a tobacco industry whistleblower, and DNA Plant Technology gets involved in this. This is just like, I can't even make this stuff up. Like I said, activists are not that creative. Truth is so much stranger than fiction. So in addition to creating the fish tomato, this company also worked on Y1 tobacco, a strain with an unusually high nicotine content that apparently the company then lied about. And the company, DNA Plant Technology, was charged with illegally smuggling Y1 tobacco seeds out of the US to grow it in South and Central America because they couldn't get permission in the US. And there's just all other kinds of craziness that this company's involved with. So, like in terms of our research, this is a Wikipedia article that we edit when we have some extra free time, and I'd encourage you guys to do it too. We like to sort of contest these ideas in the public realm because we're not formal academics in the space. So we put our research and primary source documents up on Wikipedia. So if you find anything else about about DNA Plant Technology or fish tomato, we'd love to see you on Wikipedia and other open repositories. So I think we can say that people are going to do unexpected things with technology, and we'll tell you some more about that. But what we're doing with this project now is we're cooking a soup called vegetarian bouillabaisse, which calls for the fish tomato. And bouillabaisse is a French Provençal stew that's tomato and different kinds of fish. And so we'll just put it together in one thing. And it's a bit of a hokey metaphor if you're a molecular biologist. Sorry about that. I can tell you about the subtlety later. But the idea is that we have this recipe and now we have to find this tomato. So we're searching for it. We think because it was intellectual property, there's some germplasm or seeds stored somewhere in the United States, or perhaps there's still some plants being cultivated somewhere. So we're on the lookout for it. And we would very much actually like to cultivate this plant in sterile conditions because it's important to science. There's no data about this plant. We don't know what happened with this experiment. And we continue to give people power by calling them scientists when they're not scientists. So if DNA Plant Technologies, a company, and the scientists working on this project do not provide data, we shouldn't call them scientists and give them that credit. I mean, we can call them, biohackers or criminals in some case, whatever. But they're not scientists. So we do want to find this tomato and reenact this science experiment so we could add that data to the sort of collective knowledge. So if you guys are more interested in doing some data mining for transgenics, it's obviously not hard. My freshman color theory student took him about 10 minutes to find a really interesting story. Sorry, before I get to show you how to do some interesting database stuff, I take a lot of my inspiration from this work from the Critical Art Ensemble, which is a really amazing group, and they have a book from 2002 called Molecular Invasion, and this is their 7-point plan for cultural resistance, and I think that this is a really important thing to stay focused on when we were talking about being specific earlier, because a lot of times when it comes to GMOs, people just don't want to talk about them or get into the sort of what could be interesting about them or get into the sort of controversies in a specific deep way, and following these 7 things has sort of informally allowed me to do that, although occasionally we still get in trouble at art schools. This is a group called the Center for Post-Natural History. This is a good example of doing some data mining of transgenics. They took the US database of field test applications and mapped it over time. So you can go to their website and sort of see where all the different GMOs have been grown, or I should say, to be specific, where all of the companies and universities have gotten permission to do field tests of GMOs they may or may not have, we don't know. So I wanted to teach my students a little bit about using a database and writing some stories from it. And just as a reality test, I wanted, since I was in the US, I looked at the European database of GMOs. And I found this really interesting genetically modified cucumber from Poland. You can see the number there. And it's a very sweet cucumber. And I was trying to imagine, what are they doing with this? So I invented a recipe for hyper sweet and sour pickles. I don't know if that was the plan. Maybe they were just growing it so that they could make sugar in the way that you make sugar beets. What you find when you actually investigate primary source documents is there's huge missing holes, which is why it's so important to look at these actual documents. So I had my students do that as well. I gave them access to the US database and European database of field test permits and had them write imaginary recipes for these genetically modified organisms, which have been tested but not commercialized. And I think this is useful because the students got their hands dirty with something they feel really strongly about, and they had to either reinforce or challenge their convictions. They got to ask interesting and imaginative questions, and when they asked those questions and they looked for answers from the primary source documents that companies or universities were filling out, they weren't finding answers, which made them more curious. And they had to fill in the blanks and work through the sort of minds of these companies and universities. Why is a Polish university making a super sweet cucumber? What's this about? So the website for Europe is here, and we'll provide links on the web if you want to see it later. And again, let's look for Germany. We like to be local. So here are some of the recent field test applications. University of Rostock has made a smut and fungi-resistant wheat that they want to test. Monsanto, of course, has the sugar beet. And BASF Plant Science Company has a potato that has altered starch metabolism. So there's there's been 80 applications to do live field testing of GMOs in Europe, according to this database. Oh, sorry, that's just for Germany. So you can take a look at some of those and see what stories are there, what the geographies are, why people are doing this kind of genetics work, and who does it benefit for. Okay, so we have 3 more ingredients. This is the last sort of normal ingredient. Aubergine. So our work actually kicked off in early 2010 because I teach at a university in Bangalore, India, and there was a huge debate in India about whether or not to allow a product that Monsanto was trying to sell. Monsanto's being a large former chemical and weapons manufacturer, now agricultural company, if you don't know. And so Monsanto had this product, BT brinjal, that they were trying to get into the country. Now, India already has a genetically modified cotton that they've approved, but they don't have any edible plants. So it was a huge debate. You had different people dressing up as aubergines From the US, we call them eggplants. And in India, they call them brinjal. So I'll use those three terms interchangeably. And the product was called BT brinjal. So why was Monsanto so interested in eggplants in India? And so this is where we're doing some primary source research is really interesting. This is a map of average regional eggplant output. Let's just zoom in a little bit. So this is where all the action is, India and China. And the thing about China is they have interesting intellectual property law enforcement. And they have their own state-sponsored genetic modification program, so they don't actually really need Monsanto's products, even if they wanted them. On the other hand, India is a country of 1 billion people, is the second highest producer of eggplants, and if you could just get this one national government to take this product, you'll be golden. So I think, as I was looking at this map, that was what I assessed. That's how I could understand it, that there was basically a political boundary, India, where a ton of eggplants were grown, and it only took, lobbying one government, so they sort of focused their energies there. I think the thing about companies like Monsanto is they don't hire enough creative people. And so they didn't think about the history of eggplant in India, which is great. I'm happy that they don't hire creative people. But they didn't think about the fact that aubergine is the only nightshade species that was indigenous to the old world. Like I showed you before, all the other nightshades that we eat, potato, tomato, came from the New World. So it's been in South Asia for a really long time. Again, all these awesome open source biohackers, i.e. farmers, have been making this wonderful diversity of plants for us. So there's a very strong and unified resistance from many regions of the country from many different perspectives. So obviously there are people who are concerned about human and ecosystem health. Some of those concerns I think are totally valid. Others of them I'd actually question based on the scientific research. There was concerns about intellectual property rights. There's concerns about agricultural biodiversity, which to my mind is an absolutely huge one. Excuse me. So these were just some of the images that I took at the protest in Bangalore that was organized by a variety of people. And it's everything from, you can see this one poster, Save Our Biodiversity, which is a sort of appeal to a modernist, scientific way of understanding the diversity of life, to when scientists play God, the kittens die. I don't know. There's something at the bottom. I can't read. But this is sort of an anti-modernist appeal, or an appeal that says scientists and religion, and there's different domains that people should work in. So there was a range of appeals that protesters were making. And believe it or not, all of these different things you see are forms of aubergine. So you have these tiny, hard grape-shaped ones. You have these ones with these huge spikes on the stem. There's an amazing diversity. So what I was really surprised about was the amount of scientists and policymakers that were very pro BT brinjal, I think for a variety of reasons, but there were in fact a lot of molecular biologists who were like, oh, we have a bunch of anti-modernist people from the villages, they don't know any better. If you like iPhones, you're going to love BT brinjal. So it's a sort of curious argument that was being made, and this was from a political weekly, an article called BT brinjal Need to Refocus the Debate, where these authors say, the BT brinjal debate has featured technological worries relating to genetically modified crops, which appear relatively minor in comparison to the critical issue of who controls Indian agriculture, and therefore who controls food security in India. And I think this is not a perfect statement. I would maybe disagree with the first part, but I think the who controls part is something that I could talk to molecular biologists about. I could talk to farmers about. Everyone sort of was interested in that topic, so that's where we sort of focused our energies and thought about. So along with a class of students at the school where I taught, we just went out to the markets in Bangalore and saw what kind of aubergines were available, and these were the ones we found. And so, the thing about cooking and recipes, it's actually it's actually a technological ecosystem. So you have this kind of aubergine that's long and thin, and you have to cut in a certain way, and it cooks a certain way, it tastes better this way. So there's all of these things co-evolving together. It's not just the plant genetics itself, it's how the culture uses it. And so we were trying to think about that and also document the process of de-diversification, which is already underway. Because even if there's no GMO aubergine in India, there are big consolidated seed companies nationally that are selling less kinds of seeds and selling improved varieties. And so one thing we always come back to is, what do things taste like? And so I think I missed this in the debate in 2010, but I never heard anyone talk about what GMO aubergine was going to taste like. And while it seems like maybe a silly question, if you think about it for a second, that answer a huge question that didn't come up, which is what varieties of genetically modified aubergine is Monsanto going to try to sell? Is it 1? Is it 3? Is it a suite of 30 that will appeal to regional flavor profiles? Like, this just did not come up. So we do come back to this question of what do things taste like, even things we might not want to taste. And we're starting to call this connection between ecology, agriculture, and cuisine the biodiversity of the kitchen. So the cultivars and hybrid varieties that are inputs into the kitchen become associated with flavors and preferences and cooking styles, so it's this whole big messy thing. And there's no top-down solution for that. And this is just some of the ways how food systems learn. It's not a straightforward, oh, we'll replace X with Y and all will be good. It's you replace X with Y, people cook differently, they maybe get more obese because now they're eating more sugar, so it's really complex. And so it is really important to take a holistic and inclusive approach to food systems. I'll get off the soapbox now because I see like eyes going, but I think we have some, this was the last thing from that article, just as a reminder. Who owns GM technology appears to be far more crucial an issue than its GMness. Again, it's something we can debate and have a conversation over, but I think it's a good starting point.
Our second to last ingredient is sushi, or zebrafish more specifically. So some jellyfish have this magnificent property where they appear to glow green in certain lighting conditions, and it's caused by a gene sequence that expresses GFP, which is a green fluorescent protein. And this is a zebrafish, which is a model species used in biology to study a whole host of phenomenon. And by inserting GFP into the zebrafish's DNA, scientists have created a glowing fish. And so people are going to do unexpected things with technology. And building on this innovative application of biotech, a company decided to make this new commodity available to the public by selling glowfish as pets. And they're now available in most pet shops in the US, except for in California. So very innovative. And the Glowing Sushi cooking show was created to demonstrate just how easy it is to innovate with new technologies right in your own kitchen. So how can government agencies and companies predict how a new genome will be used once it's let out of the lab? They can't really. So the glowfish was approved as a pet, but that doesn't stop us from innovating on innovation and cooking with it. The glowfish is available through the US except for in California, as I mentioned, and it's illegal in California to sell, so this is the not in California roll. This is the kryptonite roll, which is a wasabi glowfish paste, basically mashed together, spread on top of a cucumber sushi roll, or you might be tempted by the stop and glow sashimi roll. So soon we might also have another genetically engineered fish to make sushi with. The fast-growing aqua bounty salmon is currently going through FDA approval. Well, it has been for 10 years, so there was, it's not that soon. But the process for release in the US is classified as a new drug for the consumption of animals and not as the creation of a new organism. So if this fish were to be approved, what might the unintended consequences be? Perhaps, people want to raise them as pets in their backyard, but, I wouldn't particularly worry because according to Aqua Bounty's website, the fish are sterile and can't contaminate the wild environment, so, it's probably fine. So the last ingredient is smog tasting, or smog. And the marvelous thing about whipping egg whites is that if you do it right, the foam can approach 90% air, so you can make site-specific egg foams. So this was with a group of students in India again. We basically whipped eggs in various locations around Bangalore and then cooked meringues. And when you offer someone a meringue made from different locations within a city, you find out pretty quickly what their perception of the air quality is. So, you know, it's a pretty low-tech version of biosensing, but it seems to do the job. And as we say, the tragedy of the commons never tasted so good. So, yeah, I don't know if we can go to...
Yeah, we should have 2 minutes. We'll just do these quick ideas for further exploration. So we gave you a bunch of databases to look at, and we'll put those up on our website. And I just want to mention very quickly other ways you might immediately sort of do some things that, so a highly technical sort of hardware hacking thing are these raw milk vending machines that I first saw in Gijón, Spain, but I know are available throughout Europe. They might even be available in Germany, I don't know. But it's a sort of interesting technical fix for farmers who otherwise have to dump their milk because of EU regulations. They sort of behind the scenes can sell their milk using these machines, and the plastic and glass bottles are reusable. So it's a sort of interesting hardware hack that's out there. Another really amazing thing is there's this restaurant called Moto in Chicago, and they have this idea of making, they've made this fake tuna out of compressed watermelon and some sort of savory chemical, and they sous vide it. And so it's a way of doing substitution through simulation. So like if you like sushi, you really want to eat well and not eat overfished fish, but you end up doing it anyways. And I haven't tasted this yet, but it apparently tastes amazingly like tuna. So molecular gastronomy could have some answers as well. We've been looking at utopian cuisine, the history of utopian foods from the last 100 years. So things like seaweed and tofu and pill food, and this is some of our recipes we've been making. And lots of people are wanting to eat invasive species. I don't know if that's necessarily a great idea, but it's an interesting one that could be furthered. And then if you've never saved a seed, this is my last appeal. Please, this year, when you get some vegetable that you buy at the store out of a garden, save the seed. Just go on YouTube, there's a million videos. And I think you'll just learn an amazing amount about the history of pre-digital computing, which was largely vegetables. And it's sort of much more difficult and much more easy to do that than you could ever imagine. So that's my last appeal. And yeah, thanks. Do questions.
Thank you very much. We now have an audio angel going around with a microphone for the questions. And I think the IRC is quite empty at the moment, but hopefully somebody will show up there. So, the first questions, please.
Hello, my name is Geraldine, and it's not a question, it's just more like a, I don't know, tip. About all that stuff you said about lobbying for transgenics and that the action is in China and India. I think the hardcore action also is in Mexico. Like the corn, Monsanto owns corn, destroy corn, and now it's like the government also give permits to states to make pilot growth of, pilot seed test. Not a university or anything, like actually states now will be available. So if you want to just, research, I think would be very interesting because there's no good corn in Mexico anymore, even though corn is Mexican, basically. So I think it's interesting to research it.
Thanks a lot. And in fact, yeah, I didn't know a ton about the GM corn scene in Mexico because I've mostly been in Asia the last 5 years. But I'll look into it. I mean, one thing we're working on right now is with one of our chefs is a corn smut recipe because they eat the fungus that grows on corn in Mexico, right? And but it's not popular at all in the U.S. So we're sort of working on that as one of our utopian cuisines. So we can let you know about that. Thanks.
Okay, where did you get the data for the aubergine production heat map? Because I've never seen this data before.
That was there's the Wikipedia article on aubergine. The data set's in the slide notes, but I can.
But do they have the data for all the major crops, or just aubergine?
No, it's that was crop by crop, but the FAO UN data set is pretty rich. It's not so. It's just by country level. It's not by regional level, but that's.
Yeah, I've seen the country level. I'm just wondering where did I get the data?
Yeah, I think that was a much more specific data set.
Okay.
Yeah. Thanks.
Thank you for your talk. In my experience, the most interesting thing is that there's a lot of stuff around. So this concerns old kinds of apples, old wheat, and that's the most important thing is to create an economy around it. So do not leave the economy to Monsanto and other things, but create an economy, mostly local economy around the variety of things. And this is just starting, and the experience is very interesting. So you get a lot of different tastes, much fresher vegetables, and my biggest surprise was that the number of vegetables and the different tastes can completely or nearly completely replace eating of meat and something like this. So most people eat meat because there are more recipes for meat than for vegetables, but this is not true if you go into this long tail, as you said it, and explore the interesting vegetables around.
Yeah, I'm kind of excited to see how that long tail might be shifting as this trend for farmers markets and kind of locally produced food is increasing. And even in the suburbs in the US, his parents are now going to farmers markets and stuff, which they wouldn't have considered, you know, a couple years ago even. So.
There's an additional question over here.
When you experiment with food that is not marketed as food, like the glowfish, how do you find out if it's moderately safe to eat? Like, for example, I'm interested in cooking with bugs, like crickets, which exist in lots of countries, but basically in Germany you only get them as reptile food. If you buy something like that, do you know any resources where I can find out, well, if they're edible for humans?
I mean, I think as a metaphor, it's a bit like hardware hacking. You know, like I was like, oh, I'll do a circuit bent keyboard because I won't like kill myself with electricity. And then you jump into the, you know, glowing stuff. So, I mean, I think, you know, start small and reasonable. If you look at the glowing sushi project we did, we actually spent a lot of time looking at all the primary source documentation from the legal approval of it in the US. And in fact, what's really interesting is that there was one dissenter in California who said, you know, this is a pet, but there's nothing stopping like cats or children from putting their hand in and eating the fish out of the bowl. And his sort of thing was dismissed. So that was an interesting outcome. But in all of the things that we've read about, you know, eating GFP, there's been studies of people eating GFP. They think it passes through the body. There's some studies that say there's gene transfer, you know, in the gut. So it is a bit complex, and so it's sort of, you know, at your own risk. So we haven't yet fed it to anyone but ourselves. So we're just doing self-experimentation, which is one thing. So those sushi have only gone in our bodies.
But I think also it's important to know how it's been raised. For example, a lot of pet fish are in water that has some nasty chemicals in it and that kind of thing. So it's not, you know, I'd say you can probably eat, with disclaimer, but you can probably eat, you know, most bugs without getting drastically sick. But you can also, you can look on, you know, you can find out what bugs people eat already, and that's generally a good indicator of what you can eat. And there are some, I know in the UK there's a website where you can order edible bugs, but I can look for that for you. I don't remember off the top of my head.
This somehow leads to one question from IRC, and one participant wants to know if you can tell us how legal it would be to do such experiments like genetic modifications when you just intend to eat the results yourselves and not sell it.
So it's country by country. We're actually working in Ireland right now at a science gallery, and to do certain things they have to get approval from the government. And strangely, Ireland and Norway are the most lax in the EU, but there's a lot of sort of biohacking communities that are making GFP yogurt, which there's an experiment online that looks pretty simple. It's sort of an illegal gray space as far as I can tell right now. So I don't have an exact answer, but if you're going to do it formally in a research university like we're doing in Ireland, there are very set procedures about how to do it in terms of DIY. Bedroom hacking, there's a lot of really good communities out there. You can probably tap into them, but I think they're sort of discovering it as they go, what the law is.
But I think even, I think as soon as you say you're going to eat something, you get into really murky waters, because even like DIY bio guys are having problems in terms of being allowed to use their various enzymes and things. So then suggesting you're going to eat them, is another step which you have to kind of figure out. We didn't make anything ourselves, so eating off-the-shelf stuff, I guess.
And I think, we're not deep into this community, but a lot of our friends are in terms of the DIY biotech community. And I think a big debate in that community is whether to sort of go the route of making everything above board, working through universities and sort of sanctioned places, or just do it in the bedroom. And, there's been a sort of big shift over the last 4 or 5 years for a variety of reasons. So you can talk to those folks, and they have a lot of interesting thoughts on it.
You weren't completely clear on the meringue, whether it was really bad or was it good tasting when you put the smog in at different locations?
Oh, back there. You could, I think the sugar kind of masked most everything. But we did do one test which was right in front of the exhaust pipe of a big lorry. And we looked at it under the microscope, and you could see very distinct black particulate matter. And you could test for kind of VOCs and that sort of thing. I think taste-wise it doesn't make a huge difference, but I think perceptually or psychologically it makes a much greater difference. So.
Other questions?
And actually transporting the meringue once it's whipped is quite tricky. You have to be close to an oven.
We have a question from IOC again.
Yes, and one chatter wants to know if there are any means to do some kind of self-monitoring post-consumption of GMOs. So regarding the physiological effects.
I was going to say you could look at your poop and see if it glows under black light, but I think the proteins would be denatured by then.
Acids in your stomach.
I think the thing to do is to look at some of the canonical research that's done on lab animals and go from there, but I don't know specifically.
Yeah. There's also Quantify Self, who seem to like to look at very many things, so perhaps they're better at giving those kinds of tips.
Any more questions?
Transition time.
I can't see any. No, at all? Okay. Thank you for asking. Thank you for the talk.